Hello students, how are you all? Now today I am going to discuss a very important topic that is called upstream and downstream. It comes in a chapter called pair of linear equation or simple linear equation in one variable or two variable. Now before moving forward, we must understand what do we mean by upstream and downstream. Upstream means against the flow of current, downstream means with the flow of current. Now for example, when a swimmer swims or a boat moves in a water or a rower rows his boat in a water, if the swimmer or a boat moves with the speed of current, then it is said that the movement is downstream. And if the movement is against the flow of current, it is said as upstream. Now in case of downstream, the net speed is the sum of the speeds of the current and the speed of boat in still water. And in case of upstream, the net speed will be the difference of speed of boat in still water to the speed of current. Okay, I have one query, I have one question based on this asked by one of the student. The question is that a speed of a rower in still water is 18 km per hour. Speed of rower in still water is 18 km per hour. Now further the question says it takes him thrice as long to row up as to row down the river. That means when he row upstream, it takes 3 times more time than when he moves downstream. That means with the flow of current. Now here important thing is the time log. In case of downstream, let's say he takes 1 hour to swim to move across a river. So in upstream he would take 3 hours. So the equation we will try to frame in the context of time. Now let's say speed of stream or current is x km per hour. So speed of rower of boat in downstream will be 18 plus x and speed upstream is equals to 18 minus x. Now for example, suppose the swimmer or the rower takes t 1 hour to move across a river in downstream. As we know that time equals to distance upon speed. So this is the time taken by the swimmer to move across the downstream to cover up the river. Let's say T2 is the time taken by the swimmer to go upstream. Since the river is same, that means distance is same. So we will try to make the equation in the context of time. Now as I told you earlier, if this time is 1 hour, it would be 3 hours. So here we will find T2 is 3 times of 3 watt. Is it clear? Now let's put the value d upon 18 minus x is equals to 3 into d upon 18 plus x. Now since the distance is same, so it will not play any role. We will go for the cross multiplication. So I'll rub from the top. So we are having 1 upon 18 minus x equals to 3 upon 18 plus x. Cross multiply will give us 3 times of 18 minus x. Now 18 plus x is equals to 3 into 18, that is 54 minus 3. Now simply transpose this minus 3x becomes plus 3x. So x plus 3x equals to 54 minus 18. 4x equals to 36, x equals to 36 upon 4, that means 9 kilometer per hour. So the speed of the current, rate of speed of the current is 9 kilometer per hour. I hope student, I might have touched your query regarding upstream and downstream. It is a very good question, so please do mention in your comment section. Thank you so much.